Okay, good morning, everybody. Praise be to the Lord. We're going to continue with our class, science class, right? um, we're going to continue to talk about the topic of how come matter can be described. How come matter can be described? So let's go to page number 18 to continue with our reading and to continue with explanation about each topic. Okay. So let's see. Start with Roland, please.
Mass. The amount of matter in a solid, liquid, or gas is called its mass. Mass is measured by using a balance, often using units of grams or kilograms. We often weigh objects to get an idea of their mass, but mass and weight are not the same thing. The weight of an object on Earth is different from its weight on Mars. But the mass of the object is the same on both planets. To find the mass of a solid, such as a toy car, you place the object on one inside of a balance. On the other side, you place objects of no mass, such as grams, cubes. When the two sides balance each other, the total mass of all the known masses equals the mass of.
Okay. Okay. Let's continue. Let's see. Okay, we have to see in this page the mass. Okay, the amount of matter in a solid, liquid, or gas is called a mass. Mass is a measure by using a balance, often using units of grams and kilograms. Right? When often weigh objects to get an idea to their mass, but mass and weight are not the same thing. The weight of an object on Earth is different from the weight on Mars, but the mass of the object is the same of both planets. To find the mass of a solid, such as a toy car, you place the object of one side of a balance. The other side you place objects of no mass, such as gram cubes. When the two solids balance each other, the total mass of all the known masses equals the mass of the object. Okay, what is the meaning of that part? If you make a little experiment, you have a balance, right? You have a balance, and you put an object in one part. So the balance, maybe this is the balance. So the balance go to this side, right? And you start to put another object in here, so the balance start to move. When you get a real balance, like in here, like in here, right? No, Karin, you can do it. No, you can do it. If you have a real balance in here, it's because in both sides, the weight of the matter or the weight of the object is the same. Remember, in this part only you have one thing. And in this part, this one, you have a lot of objects. Now it's not with the thumb, it's with the finger. Okay? Many objects have to be in here because have to get the same mass of the other side. That is the meaning. Okay. For example, we have solid in there. The empty container on the left, if you see the pictures, the empty container of the left has a mass of 8 grams. We know this because it takes 8 cubes to balance. Each cube has a mass of 1 gram. Okay? It's explaining the experiment in here. In liquid, in liquid, now the container has water. More cubes are needed to balance the extra mass. These extra cubes match the mass of the water. So let's see how many cubes. In the first picture, we have 8. In the second picture, how many cubes do we have now? 19. 19 cubes in total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 cubes. So each the water mass weight 11 grain more, right? Because each grain, each cube weight 1 grain, okay? So if you put 11 more, it's 11 grains. So the mass of the water is 11, it's 19 grains. Let's see the next one. The next picture, gas. Gases have mass. This inner tube has more mass when it's pumped full of the air than when it's a flat. Okay. Also, that little thing that only contain gas, have his own weight. Okay. Let's see. I have some questions. Yeah. Okay. Let's see. Let's go to page number 19. Anna, read it.
Volume. The amount of space an object takes up is its volume. Volume can be measured in milliliters. You can use a graduate cylinder to find the volume of a liquid. You just pour the liquid into the cylinder and read the volume of the scale at the surface. Solid also have volume. If you put liquid in a graduate cylinder and let a solid object sink in the liquid, the solid takes up some space. The liquid that was in the space is forced to cut up. The change into the height of the liquid column tells you have the volume of the solid. Gases have volume in effect. A small mass of gas can fill a large volume. You can measure the volume of a gas using an upside-down, partially submerged graduate cylinder. Fill it with water. If you blow air into the cylinder with a straw, the bubbles will push some water out. The volume of water pushed out is the same as the volume of a gas.
Okay, very good. Thank you, Anna. Okay, the amount of space an object takes in its volume. Okay, the volume can be measured in millimeters, centimeters, meters, kilometers, as I told you. Okay. You can use a graduate cylinder to find the volume of a liquid, a cylinder like this one. Okay. I will not make, okay, doesn't see the logos. A cylinder like this one only is the measure of the lines with centimeters. This is the only thing it's going to be missed. Um, you just pour the liquid into the cylinder and read the volume of the scale in the surface. Okay, as you see in the pictures. Solids also have volume. If you put a liquid in a graduate cylinder and let the solid object sink in the liquid, the solid takes up space, some space. It's like if I put, I will make the experiment, I'm sorry. I need to do this to explain. Let's see, wait, I have my cylinder of water or of liquid, okay? If you see in the cylinder, there is a measure almost to the logo, okay? Almost to the logo of the bottle. If I put, for example, another object like this little pencil, you will see the mass of the water will grow up a little bit. What happened? What happened? Sorry. What happened if I put a, a big object in there? The mass of the water, in this case, the mass of the water will grow more. And all that space is the space of the object right now. Right? I don't know if you understand. I don't know if you have any question about that. You don't have any question? That's a mess. You don't have any question? Okay. Okay, let's continue. Gases have volume too. In fact, a small mass of gas can fill a large volume. Why? It's like water, okay? Doesn't have a shape. You can measure the volume of a gas using an upside down, partially submerged graduate cylinder. It will be filled with water. If you blow air into the cylinder with straw, the bubbles will push some water out. The volume of the water push out is the same as the volume in the gas. Okay, let's see the pictures that appear on the page number 19. Wait. Let's see the pictures of the page number 19. The first tube of, or the first cylinder says liquid. The liquid is in the graduate cylinder has a volume of 60 millimeters. Okay, 60 millimeters. In the second cylinder, have the same 60 millimeters, but they put a toy sink in the water level, and the water level went up to the 68 millimeters. That means the volume of the cart is only 8 millimeters, right? The volume, not the weight, okay? I'm talking about the volume. And about the gas, it's 25 millimeter of air gas blowing to the cylinder. The air push out 25 millimeters of water. Let's go to answer the number 3. Number 3. Sorry, I didn't see the number 2. Let's go to find the number 2. Number 2 on page number 18 said, find out. Look at the balance that has water. Count the cubes. What is the mass of the water inside the container? What do you think? What do you think? Look at the balance that has water. I'm talking about the second balance. What is the mass of the water inside that container? Remember, if I told you, no, it's not 20 grams. No. If I tell you from the first balance, each cube weight 1 gram, right? And you only have 8 grams, 8 cubes. Now let's see the second one. How many cubes do you have in total? With Diego Guardiola said 19 cubes. 19 cubes. So how, 19 cubes. And you already have 8 cubes. That is 8 grams. What is the extra weight? What is the extra weight? The only thing you have to do is subtract. That is the way. The only thing you have to do is subtract. It's a subtraction. If you have 19 in the second balance, but at the first you have only 8, you put 11 more or 11 extra cubes. The extra weight is 11 grams, right? 11 grams. Stop playing. So, what is the weight of the water? What is the weight of the water?
11 grams.
Exactly. Very good. 11 grams is the answer. 11 grams is the answer. That is the answer. 11 grams. Okay. Sorry.
Mr. Micrófono.
Let's go to answer the number 3. Okay. Let's go to answer the number 3. Look at the picture below the 3 cylinders. Explain how the mass and the volume of the air in the tube or in the water that was pushed down are alike and different. Why? Explain. Explain. Only that. I need your answers. I want to hear you explaining that. I want to hear you explaining that. Okay, you don't have the answer? Good, excellent, nice. The answer will be, and the answer have to be, the answer have to be the volume is the same. Okay, the air may have less mass because a small mass, because a small mass of gas can fill the volume. That is the answer. The volume if the same air may have less mass because a small mass of gas can fill the volume. Okay. Let's continue. Let's continue, people. I have how many students? 23 students. Well, 22 students. Don't worry, Juan Diego. Don't worry. Okay. I know it's cloudy today. Maybe it's going to rain and going to start to be a lot of problems with the connection of internet. Okay, don't worry. Don't worry about that. I know about the problems with the internet connection when the weather is bad. Okay. So, who's missing? Dana is one, and who's the other one? Jose Valenzuela, again. Okay.
Yvette.
Yvette.
Ivette está allí.
Yvette is, what is, gallita Yvette? Ay, muchachos, qué barbaridad. Se los presto para que miren ahí por la cámara, ¿sí? Ahí va. Y el viejito soy yo, vale más. Ya les pesan los años a ustedes también. Just give me a sec. Let's continue. Let's continue. Qué ofensa, dicen ahí. Bueno, como me ven, se verán, cipotes. ¿Me oyeron? Hombre.
No
Guapos no
creo.
creo, guapos no creo, porque están medio Federico, pero ahí vamos, haciéndole ganas todavía. Okay, let's continue. Let's go to page number 20. Let's go to page. Let's go to page number 20. Let's go to page number 20. Emily, I don't see you. Okay, let's see. Cesar, read it. Thank you. It's because it's sorry. It's because I saw you in this web. Oh my god! Oh my god! Oh my god! Oh my god! So for that reason, I think you wish to participate. So let's go to give you the chance. Read it, Cesar, please.
The temperature of an object is a measure of how fast its particles are moving. The higher the temperature, the faster the particles move. We cannot see a particle that makes up the object, but we can tell when they are moving faster because the object becomes hotter. Yeah. There are different scales for measure temperature. In science books, you may find the melting point of a solid in degrees Celsius. In a repeat, you may find a cooking temperature given in degrees
Fahrenheit.
Uh-huh.
Fahrenheit.
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 Fahrenheit. Knowing the temperature of solids, liquids, and gas. It's very useful. For example, the water in a fish tank needs to keep at a right temperature. A weather report gives us the temperature of the air and the temperature of your body can help monitor a health problem.
Okay, thank you, Cesar. Very good. Okay, we are going to talk about in this part about the temperature. Okay, as I told you earlier, there is two ways to measure the temperature of a region. There is Celsius degrees and Fahrenheit degrees. Okay, both of them. Okay, we can also use, for example, when we have when we look in the, for example, in here, I don't know if you can see it on the camera. Okay, right now in Tegucigalpa we have 23 Celsius degrees. Okay, 23 Celsius degrees. This is one way to measure the temperature of a region, right? To change it, okay, it's very simple to change it, and we can see if I want to use Fahrenheit. And for example, I change it, and if you see the camera, the temperature of Tegucigalpa in Fahrenheit is 73. No, it's not cold. It's fresh. It's fresh. It's very fresh. A weather very fresh. When we are in, for example, in Fahrenheit, it starts to be warm in 86. In 86 Fahrenheit degrees, it starts to be really hot, really warm. Okay, so it's in that way we're going to use it. So let's see. It's like we made when we have our, yes, I have the same, Emily. Okay, here in Santa Lucia was raining. Yes, in Santa Lucia, always, all the time, when the weather is this in this way, it's raining. Nice. I really love that weather. Okay, let's go on page number 21, and we're almost finished. Madeline, read it. Madeline, read it. The page number 21. Yes, yes.
Texture. When you touch a solid object, you can feel it. You can feel if it is hard, smooth, lumpy, gross, spongy, or raw. The surface structure that you can feel by touching a material is its texture. You can also feel the texture of a liquid by rubbing a drop between two fingers. A drop of shampoo may feel soapy. A drop of oil will feel oily. Other liquids may feel slimy, sticky, or thick. For example, people who make soap may use the texture of the liquid mixture of ingredients to decide when it is ready for the next step in the process.
Okay. Thank you, Madeline. Very good. Okay. For example, if you touch, I don't have an examples in here to explain the textures. I really don't have an examples in here. Okay, for example, it's very different to touch this wall, right? Because this wall feel rough, to touch this part of my cell phone. Okay, it's different. It's different textures. Also, with the same object, we can find a lot of textures, right? For example, in here, I can use, okay, my protector of the cell phone, right? And if you see, I have a texture in here. But in the other side, if you see carefully, I have another texture in here. Okay? As I told you, with only one object, I can find a lot of textures. For example, with a pencil, with only a pencil, I have a texture in here. If I use it in here, I have another kind of texture. Okay? Also with anything, have a lot of textures, even in your computer, your house, in that chair you sit right now, because some parts of the chair may be of wood or maybe be or wait, or water metal. Okay, some parts made of cotton and something like that. Okay, that is the explaining. Let's go to answer number 6 and number 7. We still have 6 minutes. The number 6 said, analyze. A heavy brick weighs more than a fluffy cushion, but the cushion takes up more space. Which object has more matter? How do you know? Okay. Which one have much matter? The brick or the fluffy cushion? Uh-huh.
The brick.
Exactly. If you don't know what is a fluffy cushion, it's un cojín esponjado. Okay, esponjosito. That is the fluffy cushion. Okay. That is the fluffy cushion. Okay. Now, ooh, I'm cold. Let's see. So the answer is the brick has more matter because it has more mass. That is the answer you have to write in there. Okay. Then number 7. Well, let's see the number 5. Write 2 surface with a smooth texture and 2 surface with a rough texture. You can answer, the answer will be vary actually. And the last one is, which property might be more useful to tell 2 materials apart? Their mass, their temperature, or their color. Okay. So people, let's see who didn't enter today. I didn't pass the attendance list. One is Dana. And the other one is
Antonio.
Jose Valenzuela. Okay. So, people, Imagine Learning is ready for the people who didn't enter to complete. They have to complete. And for the people who didn't enter, they have to enter and do all the activities. For the people who finish the activities, enter. I want to see you enter all the days because you need to practice. Because I check some answers of you, well, from the 15 of you who complete the activities and have some mistakes. So enter again and start to review all the activities, okay? See you at 10:50. We have the grammar class, okay? We have the grammar class. Enter. We're going to see you at 10:50. Yes, I think. I really don't remember. Okay, so see you guys to the grammar class. Bye-bye. Take care.
Bye, Mr.
Bye.
Bye.
See you around.
Bye.
Bye,
Bye,
Mister.
Mr.
Bye, mister.